In this video, we're going to talk about part 2 of partial fraction decomposition. And that's once we've set up our partial fraction decomposition, we then want to move to solving. And the way we're going to solve for A, B, and C, three unknowns, is by using a system of equations, okay? Now it could be 2 unknowns, 3, 4, 5. It depends on the rational expression that you're starting with. And so we're going to be setting up the same number of equations as we have unknowns. So if there's 2 unknowns, A and B, you'll need 2 equations. If there's 3 unknowns, A, B, C, you'll set up 3 equations, etc. Okay, so I'm going to show you how to get from partial fraction setup to a system of equations. So let me give you an example for us to work through. Let's say I'm given the rational expression 5x plus 7 divided by x minus 1 times x plus 3. So my denominator has 2 distinct linear factors. They're not repeated. So I got to go through part 1 to get to part 2. So I got to set up my partial fractions. So each of these linear factors gets its own fraction. And the numerator is always 1 degree less. So A and B. Okay. So I have 2 unknowns, which tells me I'm going to need a system with 2 equations, which is nice to know ahead of time so you kind of know what you're working toward before you move into solving it. Okay. So right here I've got an equation. Okay, I want to solve this equation for these 2 unknowns right here, right? So when working with fractions, the first thing in this equation, first thing I'd like to do is just get rid of the fractions, right? So what I'm going to do first is multiply both sides of this equation. You have to do it to both sides by the original denominator we started with, right? So I'm going to multiply this side by x minus 1 times x plus 3. I'm going to multiply this entire side by x minus 1 times x plus 3. Okay. Now over here on the left-hand side, simplifies very nicely, right? The denominator is just gone. I'm left with 5x plus 7. On the right-hand side, make sure you're distributing this. Okay, this is multiplying here. This is multiplying here. Don't start canceling stuff over here because then you're just going to get a plus b and it will be wrong, all right? This distributes here, okay? So I'm going to show all the steps so you can see what's happening. You'll start noticing these things faster, which is great. I need to show you what's happening, okay? This distributes, and then individual factors cancel, okay? So I'm left with 5x plus 7 equals a times x plus 3 and b times x minus 1, right? Cool, no more fractions, all right? I now have a nice linear equation, which is super awesome, okay? So now what I'm going to do is distribute in A, distribute in the B. Remember, when you're working with equations, it's important to keep both sides running down here, and it's important to keep the entire side. Don't do it in pieces, because you're going to lose track of what you're doing, and I'm going to lose track of what you're doing, okay? Keep everything all the time. All right. So I've got ax plus 3a plus bx minus b. And this is our first example. So I'm going to be showing more steps than I would normally show because I want you to see what's happening. All right. So what I'm going to do is collect all the x's together and all the constants together. Okay. So everything with an x. So ax plus bx. All right, this is together. And then everything without an x. So 3a negative b. So plus 3a minus b over here. Okay? This is where all the fun happens. All right? So in order to get from one equation to two, what we're doing is we're saying this polynomial right here has to equal that polynomial right there. The only way two polynomials are equal is if they have the same variables, like x and a constant, and if the coefficients are also exactly the same. I mean, 5x plus 7 is only equal to 5x plus 7, nothing else, right? So what I'm going to do here is factor out the x. Okay, I'm actually going to write it here. So a plus b times x, if I factor that x out, and then plus 3a minus b. I'm trying to make this really obvious, and hopefully it is, okay? A plus b has to be equal to 5. The only way these two polynomials are going to be equal is if the coefficient on x is 5. So that means a plus b has to equal 5, which gives me one equation in my system. A plus b has to equal 5. Also, the term without an x has to equal the term without an x. So 3a minus b has to equal 7. This is the only way these two things are going to be equal. So 3a minus b is equal to 7. And there's my system. Okay. Now this is part 2 where we're focusing on setting up these systems. Okay. In the next video, we'll talk about solving them, right? Which you know how to do. But part 3, we'll talk about solving these systems and then writing the solution. Right now, I just want to focus on this part, just setting this up. So I have another example I'd like to do. Okay, let's say we're working with this rational expression right here. Eventually, I want to do the whole partial fraction decomposition, but again, focusing on part 2, setting up the system. In order to get to part 2, we have to go through part 1, right? So part 1 is setting up the fractions. So focusing on the denominator, I have one linear factor and a repeated linear factor. So x plus 1 is here once. X minus 2 is repeated twice, so I need it here once and twice. And then each numerator will be 1 degree less. Focus on the factor, not the exponent. So each numerator here is going to be a constant. So A, B, C. There's part 1. So I have 3 letters here, 3 unknowns. So I'm going to need a system with 3 equations. All right. So first step, get rid of the fractions. The way to do that is to multiply both sides of this equation by your original denominator. It is important to write it on both sides separately. Okay, just going to wipe that out over here. 3x plus 16 equals. This has to distribute. Okay, I'm going to write a little bit less this time. So this already has a factor of x plus 1. So that's going to leave a times x minus 2 squared. This has one factor of x minus 2. That'll cancel with one of these, leaving one more behind. So plus b times x plus 1, x minus 2. And then here, this fraction has both factors of x minus 2. So those will cancel, leaving behind just x plus 1. So plus c times x plus 1. Okay. So now I've gotten rid of the fractions, which is great. I now have polynomial equals polynomial. So now I need to do some algebra over here. I'm still going to carry 3x plus 16 down here, though, so I don't lose track of it. I need to multiply this and distribute. Multiply, distribute. Okay, so I'm going to work on that. Okay, so now we need to get to the collecting terms, okay? I want to have this written as a polynomial equals a polynomial. So what I need to do is collect everything that's being multiplied by x squared. I need to collect everything that's being multiplied by x, and then all the constants, right, with no x's. So everything being multiplied onto an x squared, I've got a x squared, b x squared. Both are positive. So a plus b, right? Everything multiplied onto x, negative 4a, negative 4a, negative bx, and plus cx, positive c. And then everything without an x, or x squared. So I've got 4a minus 2b, didn't leave myself enough room, plus c. Okay, cool, those three that are left here. Now, what's really nice about collecting them up like this, that it's now very easy to match these x squared with x squared, x with x, constant with constant, okay? And that's how we're setting these equations up for our system. Now notice there is no x squared term over here. I'm pointing to nothing. It doesn't mean there's nothing you can do. It just means there are no x squared terms. This is a 0 x squared term, right? So that means a plus b has to be 0 so that I don't get any x squared terms, right? So that's my first equation. A plus b is equal to 0. This sum here has to add up to positive 3. So negative 4a minus b plus c has to be 3. And then this is equal to the constant 16. So 4a minus 2b plus c needs to be 16. And that's where we get our three equations.